Okay, so we're starting with the, can you hear me?
Yeah, I can hear you.
I'm so sorry. I thought that it was stopping, so I actually closed Zoom also. Okay, moving on to the second exercise directly and giving you the core concept as to how do we go about doing the questions. Now look here, exercise 5B. Okay, now look here. I want you to observe this. If you want to collect a sample, okay, out of, if you notice here, they've given you an example here. For example, suppose you spin a four-sided spinner numbered 1, 1, 2, and 4 a number of times. Okay, with a sample size of 5, you could get the following outcomes. You are spinning the spinner with these numbers written on it. So, and the sample size is 5. That means you're going to spin it 5 times and you're going to record the numbers. So these are 3 samples here. Are you getting it? They've
Yeah.
collected 3 samples and then they are making the finding out the probabilities of getting each number. What is the probability of getting 1? It's 1 upon 2 if you notice. Dekho, and 2 is the probability is 1 upon 4, 4 the probability is 1 upon 4. So, yeah.
Okay.
So if you want to find out the mean out of this, the mean is going to be 1 into, if you remember the formula of mean is x into px. So 1 into half, 2 into 1 upon 4, and 4 into 1 upon 4.
Okay. Yeah.
So you've got the mean is this, and the variance is obviously you must be knowing the formula, which is x square px minus e of x the whole square.
Yes.
So they have calculated the variance here, squaring this, multiplying it with the probability, and then minusing the mean square, and they're getting the variance of this. If this is in case where the sample size is 1, okay? Sample size is 1 in this case.
Okay.
That means uh, you take a random sample, okay, or sample size of 1. That means you just have to spin it once. When you spin it once, the chance of getting a 1 is half, and the chance of getting a probability of getting 2 is 1 upon 4, and 4 is 1 upon 4. But when you spin it twice, okay, and when you're taking the sample size of 2, that means you're going to spin it twice. So they've drawn the possibility diagram, and you know how to draw the possibility diagram: 1, 1, 2, and 4, and 1, 1, 2, and 4. So the okay, here what will be the score? Acha, what is the mean of the two numbers? We are finding out the mean of the two numbers which we are getting. So this mean of these two numbers is 1 only. The mean of this is also 1. Mean of 2 and 1 would be 1.5. Why? Because 2 plus 1 is 3. 3 divided by 2 is 1.5. So these are the means which you are calculating. Okay, na? And then if you make a probability table, okay, for the means, probability of getting the mean of 1 is actually 1 upon 4. How? Because 1, 2, 3, 4 out of 16. So 4 upon 16 is 1 upon 4. 1.5 has come how many times? 1, 2, 3, and 4. 4 upon 16, which is 1 upon 4. These are the simplified form. So actually what we are doing is we are recording the, we are spinning the spinner twice. Okay, and whatever numbers are coming, okay, we are finding out the mean of it, and then we are calculating the probability distribution of the means. This is the probability distribution of the mean. Okay, so this is the whole probability distribution, and then they're calculating the mean of it and the variance of this. If you notice, the mean is exactly the same. Mean is the same as of the previous. When you just spin it once, okay, and that was the sample size 1, and whatever is the probability of every single number they wrote, and then they found out the mean and the variance. The mean was 2 and the variance was 1.5. But when you took the sample of size 2, the mean is exactly the same, the variance is exactly half of the previous variance. Previously we had 1.5 as a variance, Okay, and now the variance is half of 1.5, which is 0.75. Are you getting this point? We are going to evaluate a result
Yeah.
out of this. Then they took a, then they did it thrice, and they didn't make a table out here because possibility diagram is not possible to make with three different possible outcomes. So they made a probability distribution of this. These are the means which you can get, and the probability of getting these means are these. And out of this, when they calculated the mean and the variance, the mean turned out to be the same exactly, but the variance is 1/3 of the actual, because this was of sample size 3, so 1/3 of the actual mean, which was 1.5. So 1.5 divided by 3 is actually 0.5. So the variance is 0.5 in this case.
Okay.
Here we came to a conclusion, and that is the mean. If you change the sample size, the mean
Okay.
remains the same, okay, but the variance is the variance of the variance divided by the sample size. Do you
Okay.
understand?
Yeah. Yeah.
Okay. If you take many samples, I'm reading it here. If you take many samples and calculate the mean of each sample, these mean have a distribution called the distribution of the sample mean.
Okay.
They have actually calculated the distribution of the sample means previously. A sample mean can be regarded as a random variable. Okay? Sample mean can be regarded as a random variable. If a random sample consists of n observation of a random variable x, then the mean of the mean is found, then the mean is going to be the same as the sample mean, and it is going, the variance is going to be the variance divided by the sample size. Okay. Now let's do this question. Show that for a sample of size 1 drawn from a 6, इसको कर लेते हैं हम लोग. Show that for samples of size 1 drawn from a 6-sided die numbered 1, 2, 3, 5, and 6, mean of x with sample size 1 is going to be 3.5, and variance of x is this. Work out the same with sample size 2 and variance of sample size 2. Okay, let's do this. If it's just a sample of size 1, okay, the probability of each number is going to be 1/6 only. Okay, so 1/6 plus 2/6 plus 3/6 plus 4/6 plus 5/6 plus 6/6. Add them up to 11 plus 15, 16, 17, 18, 19, 20, 21. 21 divided by 6 is actually 3.5.
Yeah.
Okay. And variance is going to be, obviously you have to square these numbers, x square.
Yeah.
Okay, so 1, 4, 9, 16, 25, and 36. And x square px is going to be 1 into 1/6, 4 into 1/6, 9 into 1/6 plus 16 into 1/6, 25 into 1/6, and 36 into 1/6. Okay, so this answer minus the mean square. Okay.
Yeah.
This is what you're going to get. Okay, fine. So I'm just quickly calculating this. Basically, I'm just keeping the denominator the same. So 1/6 plus 4/6 plus 9/6 plus 16/6, 25/6, and 36/6. Adding the numerators, 36 plus 25 plus 16 plus 9 plus 4 plus 1, 91/6 minus 3.5 square. It's coming out to be 35 upon 12.
Yeah.
Okay, work out. When the sample size is 2, the mean and the variance. See? Now, it's a fair die. Second, the probability is the same. Fair six-sided die. Okay, so 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Okay, what is the mean of these two numbers? 2
One.
divided by 2 is 1, 1.5 here. 3 plus 1 is 4 divided by 2 is 2. 5 divided by 2 is 2.5. 6 divided by 2 is 3. 7 divided by 2 is 3.5. Okay, 3 divided by 2 is 1.5. 4 divided by 2 is 2. 2.5 here, 3 here, 5 plus 2 is 7, 3.5 here, and 8 divided by 2 is 4. This is going to go like this only. 4 divided by 2 is 2, 2.5, 3, 3.5, 4, 4.5, so on and so forth. 2.5, 3, 3.5, 4, 4.5, and 5. And 3, 3.5, 4, 4.5, 5, 5.5. And obviously 3.5, 4, 4.5, 5, 5.5, and 6. Okay, let's make the distribution of the mean here. 1, 1.5, these are the means. 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, and then we have 6. This one. Okay, 5.5 and 6. Okay, 1 has come how many times? It's just once. So the probability is 1 upon 36. Are you getting it, Vita? What are we doing?
Yeah, I'm getting it. I'm getting it.
Okay, fine. So 1.5 has come twice only. Just let's quickly do it. 2 upon
1 by
36. 2 has come thrice. Hai na? 2.5
Yeah.
has come 4 times. 4 upon 36. 3 has come 1, 2, 3, 4, 5 times. 5 upon 36. Must have come 1, 2, 3, 4, 5,
6 times.
6 upon 36. 1, 2, 3, 4, 5
One,
upon 36. 4 upon 36. 3 upon 36. 2 upon 36. And 1 upon 36 times. Okay, let's find out the mean. This is not the mean of, this is the mean of the mean actually. Okay, mean of the means. Okay, so it's going to be summation x px. It's going to be 1 into 1.6. Sorry, 1 into 1 upon 36, which is this. 1.5 into 2 would be 3 upon 36. 6 upon 36. Are you getting what am I doing?
Yeah.
2.5 into 4 is 10. 10 upon 36 here. 3 into 5 is 15 upon 36. And 3.5 times 6 is 21 upon 36. 4 into this would be 20 upon 36. 18 upon 36. 15 upon 36. 11 upon 36. And 6 upon 36. I'm just adding the numerator. So 4 plus 6 is 10 plus 10 is 20. 20. 4, 10, 20. 20 plus 15 plus 21. 20, 18, and 15, and 11 and 6. 126 total. 126 upon 36, which is 3.5. The mean is the same. If you notice, the mean previously was also 3.5. Now it is also 3.5. But if you find out the variance, which is where you have to square these numbers, would be 1, 2.25, squaring these numbers here, 6.259, 12.25, 16, 20.25, 25, and 30.25, and 36. समेशन x square into px करना है अभी हमें, ठीक है, x square into px. So you have to multiply this by this, ठीक है ना? Okay. You want me to complete the whole question?
That's
Okay,
fine.
let's do it.
I
then.
get it. I get it.
You get it? So
Yeah.
I can do it. There's no problem with that, but that is just wasting our time. 2.25 into 2 upon 36. Take enough 4 into 3 upon 36. Okay, 6.25 into 4 upon 36. 9 into 5 upon 36. Likewise, 12.25 into 6 upon 36. 16 into 5 upon 36. 20.25 into 4 upon 36. 25 into 2 upon 36. 30.25 into 2 upon 36. Okay, fine. And then 36 into 1 upon 36. Whatever this answer is, whatever is the total minus 3.5 the whole square is going to give us the variance. And this is actually going to, because the sample size is 2, this is going to be exactly half of this variance. So
Okay.
35, this will turn out to be 35 upon 12 divided by 2. So 35 upon 24 will be the variance. Got it?
Yeah.
Okay, moving on to the book now. Fine. देखो, central limit theorem actually is when the sample size is large. And देखो, there are certain questions where we know that the distribution is normal distribution. So we apply the normal method, okay? But sometimes there is not, the distribution is not normal. Sometimes it is not known to us, and sometimes it is known that it's a Poisson distribution, or it is a binomial distribution, or it's a geometrical distribution, which are discrete distributions. But the central limit theorem makes it so easy for us. It says whenever the sample size is large, greater than 30, okay, the sample size is greater than 30, then you can approximate any distribution, either any discrete distribution. It can be a Poisson, it can be binomial, it can be any other distribution to normal, and you apply the same method as the normal distribution to find the probabilities. You understand? But this is only when the sample size is more. ठीक है ना? This book says 30, the other book says 50, but take it to be 50 then. If the sample size is greater than 50, then you can apply the central limit theorem. You can go through it if you have the book. You have the book with you. So you can just read it. It says that even if the distribution is not normal, strictly normal, it is some other distribution. Either it is known or it is not known, but the sample size is large, then you can apply the central limit. Because of the central limit theorem, you can apply normal distribution to any distribution. Okay, so I'm doing questions of this. You'll understand how to go about doing it. Okay, and they've given you examples here of 3 different, the first example which they have given, the example does not mention any distribution here. It is giving you the mean and the standard deviation here, and it is giving you the sample size. The other distribution, it is a continuous random variable, but it does not actually, because continuous may be normal hai or dusre bhi hai, but it does not say strictly normal, but you can apply the method of normal distribution for this as well. Okay, and the rest of the two, this is an example from Poisson, and then there is an example from binomial which they have given. So, so you can go through the examples. I'm not doing the examples with you. You can do the examples because they are done in the book, so that will be helpful for you. I'm doing the questions which they have given us in exercise 5.
Okay.
So at least we can cover 2 exercises in today's class, and the rest, the third exercise we can do in the next class.
Miss, I have a question. Not regarding this, just for like on Friday, could we have our class at 9? Would that be possible?
Not a problem with me because Friday morning I'm free.
Okay, so
Okay.
on Friday, just this Friday though, can we change it from 10:30 I think to 9:15?
Okay, okay, sure.
Okay.
Sure. Okay, it says the first question. Okay, it says a random variable x has mean 6 and variance 8. It does not say that it follows normal distribution. The random variable x is the mean of a random sample of 80 observation. It's more than 50. State the approximate of distribution. Approximate distribution you can always shift it to normal distribution of x, giving its parameters. And you know, in order to give the parameters for a normal distribution, you have to give the mean and the standard deviation. Okay.
Yeah.
So the parameters would be the mean, which is 6, and the variance, which is 8. Right? So
Yeah.
x has a normal distribution with mean 6 and variance is 8.
Yeah.
And find the probability that the sample mean is less than 6.4. Now you apply the properties of normal distribution. You want that sample mean to be less than 6.4. Okay, so standardize it. Z is less than 6.4 minus the mean upon the standard deviation. You understand the method? How do we
Yeah.
standardize? Okay. So whatever the distribution is, if the sample size is greater than 50, you can approximate to normal. And for normal, obviously the two parameters are the mean and the variance. So you write the mean here, variance here, and you apply normal method. Achha, isme you don't have to even apply continuity correction here.
We don't have to apply what? Sorry, I didn't hear you.
Continuity correction.
Okay.
You understand what is continuity correction?
I think so, but could you just
हाँ, I'll explain you. ठीक
Okay.
है अभी इस वक्त let's complete the question and then we'll do it. Just a minute. Okay, fine. So let's do this question. It says the sample mean is less than 6.4. ठीक है, 6.4 minus the mean upon the standard deviation. Use the table to get this. I'm using first calculating this 6.4 minus 6 divided by square root of 8, which is 0.141. Okay, so
Yeah.
obviously 0.141 is going to be this part, 0.141, and use a calculator to get the probability. You know how to do it?
I did.
0.141. Probability is coming out to be 0.556. Clear?
Okay, yeah.
Okay. Moving on to the second question. A random sample X has mean 30 and variance 36. The random variable X is the mean of a random sample of 100 observation of X. State the approximate distribution of mean of X and giving its parameter and find the probability that the sample mean is greater than 31. Okay, so this has a normal distribution with mean. I made a mistake here. Since beta, you have a sample of size 80, so you have to divide it by 80 here. And here also you have to find out square root of 8 upon 80. You understand?
Yeah, okay.
Right? So because we know that the mean is going to remain the same, but the variance, the actual variance will be divided by the sample size. This is what we discussed in these questions which we've done. Okay, so the mean used to remain the same. Mean of the population is the mean of the mean. But the thing is that the variance is actually divided by the sample size. So for here also you have to write 8 upon 80, and here also, since you have to write down the standard deviation here, so 8 upon 80 ka square root and solve it and get the answer. Okay, so I'm just completing this. 6.4 minus 6.
1.26.
1.26 is the probability.
Yes.
So you have to find out probability that the sample mean is greater than 31. Just a minute. I'm muting for a while, okay? Just a minute. Okay, okay. Fine. So greater than 31. So it's going to be probability Z is greater than 31 minus 30 upon square root of 36 upon 100. So it's going to be probability Z is greater than 31 minus 30 is 1 upon square root of 36 upon 100. So 0.36 per square root, which is 0.5, 0.6. So 1 divided by 0.6, which is 5.3. 1.67 here. So yeah, make the curve 1.67 here. Greater than this you want. So simply use the calculator. The probability is 0.047. So yeah.
Wait, Miss, how did you get that on the calculator? I didn't get that.
You are using how did you get this probability? This is the one which you told me. You use the calculator, yes or no?
Oh wait, no, Miss, this wasn't the final answer.
Oh, this was actually 1.26 is this answer.
Yes, Miss.
Yes?
Yeah, yeah.
Oh, acha, acha. You don't know how to use the calculator for normal distribution?
I forgot how to do it.
Okay, I'll tell. No, I have to tell you. Come on, go on to the menu,
Yeah.
press 7. It will go on to distributions. Go on to normal CD. Okay, normal CD pe jao beta. Okay, now look here. What is it? Greater than 1.67. So this is the lower limit. Okay. Upper limit can be anything. Greater than 1.67, write down 1.6 in the lower limit and write down any big number in the upper limit. You can write 1,000, you can write 5,000, you can write any number. Okay. So write 5,000 there in the upper limit and press equals to sign. What is the probability which you're getting?
Wait, Miss, I don't think I have the same menu as you.
Which one do you have? Can you send me the picture of your calculator
Okay.
quickly?
Miss, did you get the picture?
Oh, you don't have the one which I was talking about. This is not the one. Mine is different. I'll send you the picture of mine. Okay.
Okay.
And if you buy that, things will become really, really easy for you.
Okay.
Mm. This is the white one, white calculator. It is the ClassWiz series 991EX.
Okay.
Got it? Acha, the
Yeah.
thing is, what we do is, and with the calculator, we go onto the menu, we go into the normal CD, and then we put the lower and the upper limit, and we get the profit.
Okay.
Here you have to use, because you don't have that, so you have to use the normal distribution table. So shall I you do it with the normal distribution table now?
Okay, yeah.
I can explain. Okay. So I'm explaining it to you with the normal distribution table, which is here with me. Just a minute. I'm taking it from the book then. Oh, I do remember I have it here in S1. It's a this is a table. Take it.
Okay.
So we had to find out.
The 1.2
We had to find out what?
or 1.6.
1.6 greater than 1.67. Okay, so we have to do 1 minus 5 of we have to do 1 minus 5 of 1.67. Yes or no?
Yeah.
Hannah?
Yeah.
Okay. So 1.67. 1.67 would be this. 1.67 is this number. Yeah, 0.9525. Yeah,
Okay.
0.9525. So 1 minus 0.9525, which is it's the same 0.047. Sorry?
Okay.
0.0475. This is how it would. Okay. So we got this answer. Now we're doing the third question. The random variable y has mean 21, standard deviation 4.2. The random variable y is the mean of a random sample of 50 observations of y. State the approximate distribution for y. So you will say y will be normally distributed with mean 21 and variance is 4.2 square upon 50. You understand?
Yeah.
Okay, state the approximate distribution of y. This is the answer for the first part. Given its parameter and work out y is less than 20. Mean of y is less than 22. It is going to be equals to probability z is less than 22 minus 21 upon square root of 4.2 square upon 50. Okay, so I'm solving this. 4.2 square divided by 50 square root of the answer. 1 divided by the answer. So this is giving me z is less than 1.68. Probability z is less than 1.684. Okay, less than 1.684, you have to make this 1.684 is this number. You want this, so you will have to find out 5 of 1.684. Okay, so use the table. 1.684 would be the same line
0.9535.
1.68. Okay, 1.68 from here and 4 from this column. We've got 4 here. So you have to divide this number by 10,000 and then add. So obviously it will become 0.9539. Get it?
Yeah.
0.9535 may you have to add 0.0004, which is 0.9539. Okay, the next question. The time taken for the telephone call to a call center to be answered is normally distributed with mean 20 and standard deviation 5. Find the probability that 6 because since this is already normally distributed, the sample size does not matter here. You can use the same method too. Okay, so I'm not doing this question. This is the same as the previous one. Since just the point which I had to explain here is that If it is normally distributed, that even if the sample size is 3 only, that does not matter. You have 2 or 3 or 1 even. So you have to use the same method.
Okay.
Okay. So I'm going on to the next question. I lost the page. I'm so sorry. Page number 106, I think.
Miss, for homework, can you send me questions from the other book?
Sure, I will. But there the sequence is a bit different. I'll see to it and I'll send it to you, inshallah. Just remind me, give me a reminder. I will. Good that you do it from 2 books. There's no problem with that. Okay, I'm doing, although the time is already up, but I want to complete the topic, so I'm taking another 5 minutes. Okay. So I'm doing one question from Pozon.
Okay.
So this one. And one from binomial. Very quickly. Just giving you an idea as to how to go about doing it, and then you can complete it. Taking binomial first. And then Pozon. Okay, a random sample of size 60 is taken from the random variable x. Okay, x is a sample mean. Fine. Okay, fine. First of all, we know that this is n and this is p, so we can easily find out the mean. Okay, so expected value of x is going to be np, which is 45 times 0.4, which is 18. Okay, and npq is the variance, which is 45 into 0.4, which is 18 into 0.1 minus 0.4 is 0.6. npq, sorry.
Okay.
So 18 into 0.6, which is 10.8. So you can say that x has a x can be approximate to the normal distribution. The mean is 18 and the variance is 10.8 upon the sample size, which is 60. Okay, you want to find out probability x is less than 19, so it's going to be mean of x is less than 19, so it's going to be z is less than 19 minus 18 upon
Square root of 10.8
upon 60.
Yeah.
And then get the probability. Say, Anavita, you know how to find out the probability. I'm
Yeah.
doing question number 8, which is the Poisson distribution.
Okay.
It says a random sample of size 50 is taken from the random variable x, where x is a Poisson distribution. And you know the parameter of Poisson distribution is actually the mean only. So the mean is 2. And we know that in a Poisson distribution, the mean and the variance is exactly the same. So the
Okay.
mean x can be approximated to normal distribution where the mean is 2 and the variance is 2 upon the sample size, which is 50. Is this clear? Mean and variance is the same in Poisson distribution.
Okay.
So then you have to find out the probability that the mean is in between 1.5 and 2.2. So you will have to change it to z 1.5 minus mean upon the standard deviation.
Okay.
You understand? Achha, I was talking about continuity correction. Generally, when we change from a discrete distribution to a continuous distribution, we have to apply continuity correction.
Okay.
Do you remember? When you apply when you use normal in place of binomial, or you use the normal approximation to binomial, you always used to apply continuity correction in S1. But here we don't have to apply. Like if it is, say, I'm giving an example, x is greater than 2, so you have to greater than 2, you have to take x is greater than 2.2 minus something, minus mean upon standard deviation when you change it into z. So you have to take 2.2, 2.5 greater than 2.5 lena. Or if it is probability x is less than 2, for less than 2, you have to take probability x z is less than 1.5 minus the mean upon the standard deviation. So we used to apply continuity correction, change this to a number 0.5 before this or 0.5 after that. There was a method for that. Okay. Well, that was very simple, but here we don't have to apply because the sample size is very large. Minus 2 upon 50, and then whatever the numbers come here and here, you have to apply find out the probability through the table. Clear?
Okay.
You want me to complete this question?
Yeah, okay.
Okay, can you calculate this for me? I'm calculating this. Okay, fast.
It's minus 2.5 is the first one.
Minus,
2.5.
and this is 1 year. Okay, so
Yeah.
you want, you will always make the curve. Okay, minus 2.5 here and 1 year. You want this probability.
Okay.
You want this area.
Hmm.
So it's, how will you write it down? You write phi of 1 minus phi of minus 2.5, which is actually phi of 1 minus phi of the positive number. You know ना
Okay.
कि negative phi
Yeah.
निकालने के लिए 1 में से subtract करते हैं. It will become phi of 1 minus 1 plus phi of 2.5. So phi of 1 plus phi of 2.5 minus 1 करना है. Phi of 1, we can use the table here. Phi of 1 is 0.8413. 0.8413.
8413.
0.8413. And phi of 2.5, you have to look into the table. Phi of 2.5 is 0.9938. No,
Okay.
2.5 बोला था ना, sorry, I'm so, हाँ ठीक है, 0.953, 0.9938. 0.9938. Add them up. 0.9938 plus 0.8413 minus 1, and you are getting 0.8351.
Yeah.
कितना time लगा आपको? देखो, you had to sort this out and you had to, and now I'm using my calculator. ठीक है, normal CD में जाके I'm putting the lower limit as minus 2.5 and upper limit as 1 directly, and I'm getting the same answer, 0.835.
Okay.
It reduces the time, it reduces the stress, it reduces the chances of making mistakes.
Okay.
You understand what I'm trying to talk about? So better if you use the calculator if you can buy it. Otherwise, it's okay. We can keep on doing it this way. I don't mind. I know both the methods.
Okay.
Okay. Okay. One more question I have to explain, and then we can just wind up the class. I'm taking some more time here. I'm so sorry for that. Question number 6. Just explaining, I'm not doing the whole thing, but just to give you an idea so that you can do the whole exercise by the next class, which is on Thursday. But please see your message by Wednesday night. The reason is I have a plan of going somewhere on 23rd of March, and if I stay there, then morning I won't take the class. Thursday at night I will take your class then. But I'll inform you. Okay, na? I'll inform you. I'm going to inform you in advance. Don't worry about that. Okay, this is the same thing, continuous probability distribution. We did it in the last class. The length in centimeter of an electrical component produced by a company may be considered to be a continuous random variable x having probability density function as follows. Okay, they've given you the function, calculate the probability that the mean. Achha, for this, you have to calculate the mean. If you remember, how do we use to calculate the mean? We used to multiply the function, which is 5 upon 2 by x, apply the boundaries on them, differentiate it 5 upon 2. It's going to be x square upon 2. Apply the boundaries 2.2 and 1.8. This is how you're going to get the mean.
Okay.
Okay, na?
Yeah.
And then for variance, we used to do what? We used to apply, square it, integrate it.
Yeah.
This is going to integrate this, and then from this we are going to subtract the mean, square of the mean.
Yes.
Remember?
Yes.
So you will integrate this. This will become x cube. X cube upon 3. 2.2, 1.8. Okay. Apply the boundaries. Whatever is this answer minus the answer of mean squared
Is the variance.
Is going to give you the variance. And once you get the mean and the variance, you can approximate this to normal distribution. Okay, write down the mean here, variance here divided by the sample size, which is 40. Okay, so the mean is going to come here, the variance is going to come here. Are you clear with this much?
Yes.
First part, you have to calculate the probability that the mean of a random sample of 40 of these components greater than 2.05. So you have to find this in the first part, and second part mein also it's going to be somewhat like this only. ठीक है ना? So then now you apply normal distribution. Convert it into z. Probability z is greater than 2.05 minus the mean here upon this answer. सही है ना? And do it the normal way. ठीक है. चलो. Thank you so much. Allah Hafiz.
Okay.